cheek. You hold it up, and you look directly through. You look straight through the top, through that rifle sight notch, and through to the line, and directly at your target. And make sure, of course, it's level, that there's no levels. But make sure, notice that this part of my hand is touching my cheek here. That keeps it very level, and make sure that my eye doesn't wander around, and that the compass isn't wobbling very much at all. Then, I can glance down and read bearings directly off that direction travel mark, and if I can see the needle, I can even line it up. The mark directly, assuming that's the direction I'm going. This won't work quite right because your eyes are different than this camera we're using, but approximately this is what you're doing. You look straight forward through that notch and you see the wire. And though we don't have one here, just pretend there's a tree on the horizon that you line up perfectly with that. And when you glance down, you can see inside the capsule. And you can read, though the field of view is much narrower here in this camera, because it's a camera, not your eyeball. You can still see that there's the direction travel line is visible. Occasionally you can read that. You can at least tell there's red numbers and letters. And you can see the compass needle is pointing. And what we were doing there requires a couple little more explanation we're going to do here at close range. One is that I was moving the housing. I find it easiest, there's any number of ways to do this, but to reach around. Don't try to grab it from the top or reach around from underneath. So remember how I had your fingers tucked in there? That's so you have a fairly small base here. You're going to put your hand around that, reach up around, and then the graduation ring is grooved and it comes right to the outside, so you can easily grab it with your fingers and move it around. You might find it easier to go inside, interlace yourself, and move it like that. Again, it depends on your own personal physiology, what you're comfortable with. But that means you can do this while that's up to your head. So what you're going to do is there are several methods. You might even find your own to make sure, of course, it's actually working right. But the most common ones are, if you're taking a sighting, for example, and you want to walk that bearing. So what you want to do, so let's say this is the way the sighting worked, and the compass is folded up and you're looking down it. And you can see where the compass needle is through the lens. You can look down and see all that. All you do is turn the graduation ring until the two bars line up. There's a little parallax, which means the needle is below the surface on which the graduation ring is based. So the lens tends to disregard that fact that there is some parallax, so be careful with that. Make sure it actually makes sense. But then, if that's all set right, all you have to do is now you're set, and you can do the center hold method, or you can keep sighting, and then you walk that bearing. The compass is set, and you're ready to use it. You can also read the bearing off and do math, write it down, give it to somebody else. You can take a reading, and somebody else can be locking to their compass, or calling in artillery fire, for example, if you need to be calculating directions, or looking it up using the compass and the map. And if you do that by yourself, make sure you write down numbers. Don't just try to memorize or lock them in to do that. Make sure you're writing things down if you're trying to do calculations or plotting things. One of the other things you can do sometimes, and we're going to go ahead and adjust this off, is especially if the needle is way down here and you can't necessarily see it. For example, my eyes are strange, and I can't clearly see this entire field of view the way that I normally hold the compass. I only see up here somewhere. It is possible to simply use this to lock the compass. Again, while you're holding it sight nicely on target, then you take it and you figure out which side is the north-facing one, and you twist the graduation ring with it locked. Then you unlock it, and you go to work. Obviously, here we'll just do that. You can tell that this being a large, solid piece of metal, it obscures some things. You won't be able to read some marks. Sometimes you can't tell where the north part is without tilting the compass, or maybe you can't even see it at all. So it's not an infallible trick, but it's a nice, quick way to do things. If you're going to read numbers and set the compass separately, or if you're going to input, if you've been given numbers and you're going to input them, it is fairly hard to do that all floating in the air. It's not terrible when you're sighting it and you're holding it up to your cheek, but simply holding it like this, it's almost impossible to really get things sighted in. So this works very well setting on the ground. And we do mean ground. Remember that unlike this device it's sitting on also, many tables have metal behind them. Vehicle hoods, of course, are giant pieces of metal. We mean ground. Pure wood things. Most field desk tables most field tables, but not field desks, are of course solid wood. But most of the ground is almost always not magnetic. So you set it on a map on the ground, and then do your settings there. So if you found you were given a number like 040, you turn it. You can even close one eye and line up the direction travel line on the compass housing, and then twist your graduation ring to line it up. And once again, you're ready to go. At night, things are a little teeny bit different. First of all, I want to tell you that we're faking this one. The tritium is a little bit too dim for cameras to see, although once your eyes are acclimated, you can see quite well. So this is a phosphorescent compass that I'm going to hit every once in a while with an ultraviolet light to make it glow better. The basic parts that glow, I'll turn it to the side so you can tell, are the direction of travel lines up here, the compass needle and the graduation ring have similar sized tritium bars. There's the west and east letters that you can see around the on either side of the compass needle, and there's a backlighting underneath the direction of travel line, which allows you to see that line so you know that you can tell where that 0 is, and also allows you to read the numbers directly off the compass, as you can see right here. My eyes aren't very good, so I find it hard to do this stuff, but all you have to do is let yourself acclimate to it. So if you're trying this right now on your own in the room, go ahead and get in a dark room and wait 20 minutes for your eyes to get used to the dark before you can really adjust to seeing things. As you can see, and like I said, these stay illuminated for full time and can easily be seen when it's tritium and human eyes. I can see this compass very clearly, for example, right now. You can see the direction of travel lines very easily, and you can glance down and tell which way you're facing. For example, the reason that the brightest bars and two equivalent size bars are on the compass needle and the graduation ring is so that all you have to do is line up the two equivalent things, as is now shown. Now we're about 5 degrees off course, and now we're much more off course. It's going to be impossible to show, so I won't do it. I'll just describe it. But folding up the compass is often the best. It does still work just fine at night. You'll have to be patient, make sure your alignment is correct, and you may need to use a second eye open in order to sight on objects nearby. But it's an excellent way to make sure that you're still being very on target, and definitely tracking to the right course, and finding numbers so that you can plot them and describe them to other people, even in the dark.